doing today?
Good. How are you?
Okay, we're doing ACT today. We can do whatever you'd like to do. Do you have any leftover questions from last night's material?
No, I turned in all of my material today, so I have no new math material, and we haven't focused on the ACT stuff in a while.
All right.
It'd be a nice break.
My notes say that we got through question 30 3 weeks ago. This was question 30. Remember what the cosine of A is?
It's in my notes that we did. But do you want to do 30 again?
Yeah, you should know this one. This is a pretty easy one.
All right, is it the a squared plus b squared equals c squared?
True. In other words, cosine of A is adjacent over hypotenuse, and we don't know the hypotenuse, so we have to figure it out.
Adjacent over hypotenuse, so the 5 over 12.
No, that would be opposite over adjacent.
Oh, so we need to do a squared plus b squared equals c squared first.
To find the hypotenuse, exactly.
Find hypotenuse, okay. All right, so it's 144 plus 25.
So what's the hypotenuse?
13.
Okay. Now, which makes the cosine of A equal to what?
12 over 13.
Okay, cool. Now, there are two special right triangles that you should memorize and recognize when you see them. And that is a 3, 4, 5 and a 5, 12, 13. In other words, if you recognize this as a 5, 12, 13, you'd have saved yourself 30 seconds on doing the math. Right?
Yeah.
And the thing is that they probably have 10 questions on this test that involve either that triangle or that triangle. Now, it won't always be 3, 4, 5. Sometimes it might be 30, 40, 50. Or 6, 8, 10. In other words, it might be a multiple of that. And it's quite likely that they might give you something like that, where they would give you the 6 and the 8, and you'd have to figure out that that's 10. Usually when you're dealing with a 5, 12, 13, and this incidentally is the lowest, and that's the second lowest. In other words, there are no other triangles with integers that meet these requirements. So that's what's special about these two triangles, is they're the lowest perfect Pythagorean triangles. And because of that, they just throw problem after problem at you that has 2 of the 3 sides are, fit these conditions. And it actually saves you quite a bit because it really does save you about 30 seconds not having to go back and solve the triangle for the hypotenuse. What's the numerator? Well, how are we going to do this problem?
Combine like terms.
Well,
On the top and the bottom.
yes and no. the way I like to think about doing these problems is let's do the number first, then let's do the letter A next, and finally let's do the letter B. So what's the number going to be? Hold on one moment. In other words, the number is going to be 13 times negative 8 divided by 4. What number is that?
26.
Positive or negative?
Negative.
Is it in the numerator or the denominator?
Neither. It's its own number.
Actually, it's in the numerator. In other words, I can reduce that to minus 26 over 1.
Yes, awesome.
Okay? And that's a good start because that eliminates A, it eliminates C. So now we're down to the possible solutions being B, D, or E. Okay? The next thing to figure out is the A's. We have A squared times A cubed divided by A squared. What does that give you?
It's 5 over 2.
What's the net?
What do you mean?
Well, what is this equal to?
Oh, it's a 5/2.
In other words, you can't give an answer of 5 over 2. That's not on there.
Oh.
You have to break this down and come up with, is it A to what power?
3.5.
No, that cancels with that. You just have A cubed in the numerator.
Oh.
Okay. And you could also do it A to the 5th. In other words, by doing the numerator over A squared, and that's where you got your 5 over 2. But when you have division going on, you subtract the exponents, and so you still come up with A to the 3rd. Okay, so now our choices are B, not D anymore, not E, we're done. We don't even need to do the B variable. There is only one choice on here that has a minus 26 in the numerator and an A cubed in the numerator. And a lot of problems like this, I see it over and over and over where you've solved it by the time you get to the A variable. We don't even have to fool with the B variable. But just for sake, make sure you know how to do this. This is the B variable. What's that equal to?
That is equal. We can't cancel it out this time.
That's right. What's the numerator equal to?
20 over 6.
No. When you are multiplying with exponents, you add the exponents.
Oh.
You always do one level less than what is being done to the base. Let's go over that. A squared times A to the 3rd, that's multiplication going on. So we're going to do not multiplication with the exponents, but addition. Okay? If we have A to the 7th over A to the 5th, that is division. So we're going to do one less level with the exponents, which is what? What's this answer?
Subtraction, and that is 2.
And finally, if we have A squared all to the 3rd power, which is what I like to call double exponentiation, but what the book probably calls it is just exponentiation. What's one level less than exponentiation?
Multiplication.
Which is A to the 6th. So those three rules are what govern how you treat variables and exponents. In other words, any problem like this can be completely solved by these three rules. So make sure you memorize those. If you might want to keep a sheet of rules, basically. And by the time we did 2 or 3 practice tests, you might have front and back of this sheet covered. But then you would have something to memorize. In other words, there's no way you want to go into that ACT test without knowing these exact. You don't want to ever make a mistake on those. Pretty simple. When you're doing multiplication, you add. When you're doing division, you subtract. And when you're doing exponentiation, you multiply. All right. What is a right isosceles triangle?
A right isosceles triangle. It's a right triangle with equal sides.
Okay. Something like that. Which of those answers could be a possible answer? Could F?
Yes, because it has 2 2's. Those are equal to each other.
F.
Oh, F was the top one. No.
Okay. Can G?
Yes.
Well, the problem with G is if I make that 2 and that 2, this is not 2. Triangles that have 3 equal sides are equilateral triangles. So you could have an equilateral triangle, but all of these are 60, 60, and 60. And that's not what this is. This is a right isosceles. Only, in fact, when they say isosceles triangle, you can assume that only 2 sides can be equal, not 3. If all 3 sides are equal, they're going to call it an equilateral triangle. So the moment you see isosceles triangle, you immediately know that only 2 sides are equal. So that rules out F and G and H and J. K is the only triangle there that has precisely 2 sides being equal. And if you use the Pythagorean theorem to solve for the hypotenuse on this triangle here, you get that.
Yeah.
Now, there's another principle in triangles regarding what sides can be. Can I have a triangle whose sides are 1, 2, and 5?
I suppose it'd just be a mean triangle.
No.
A lean.
There's a rule for triangles. Any side has to be less than the sum of the other 2. And if you can memorize that, and the reverse, which the reverse means greater than the difference of the other 2. So when I gave you a 1, 2, 5 triangle, doesn't work. 5 is not less than 1 plus 2. You can't have a triangle like that. Let's examine that a little bit closer. I could not even have that triangle, 1, 2, and 3. Let's examine how we would have a 1, 2, 3 triangle. Well, if that's the notice that the shortest distance between 2 points is a straight line. So if the distance of that base of that triangle is 3, then there's no way the sum of these two sides could be 3, because that would violate the principle that the shortest distance, in other words, the shortest distance between these 2 points cannot be the path of these other 2 sides, because that would be 3, and that's not the shortest distance. The shortest distance has to be a straight line. So I cannot even have a 1, 2, 3 triangle. A 1, 2, 3 triangle would look something like straight line. In other words, that would be the 1, that would be the 2, and that would be the 3. So that's where this rule comes from, that any side has to be less than the sum of the other 2 and greater than the difference of the other 2. In other words, I could also not have a triangle with those sides. 1/2. Because 1/2 is not greater than the difference between 2 and 1. This is kind of an unusual rule that a lot of people, even immediately coming out of geometry, they wouldn't necessarily know this. They don't tend to teach this in geometry that much, but they do expect you to know it for the ACT exam. And the nature of the question would be, which of the following could be triangles? In other words, kind of similar to this, but this one does not use this rule. Okay? Notice that F can't even be a triangle. 3 is not less than 1 plus 2.
That makes sense.
G can be a triangle. H can be a triangle. J can be a triangle. And K can be a triangle. But the only one that can be a right isosceles triangle is K. But the beauty of this rule is you only have to memorize the first line. And it applies to all 3 sides. In other words, if I said, can this be a triangle? Yes. 5 is less than 6 plus 7. 6 is less than 5 plus 7. And 7 is less than 5 plus 6. Also, 5 is greater than 7 minus 6, so it satisfies the second part. 6 is greater than 7 minus 5, and 7 is greater than 6 minus 5. So I can definitely have a triangle whose dimensions would be 5, 6, 7. It satisfies both ends of this for every side. And this is critical. It's any side. I could even say any or every. In fact, it's more correct to say every side. Every side of a triangle has to be less than the sum of the other 2 and greater than the difference. So if you memorize this, the second part, just memorize the opposite. In other words, the opposite sign there and its difference instead of sum.
I got that down.
Okay.
Written down.
Now we're getting into the area that tends to be a little bit harder. And in fact, in my ACT session yesterday, the student told me that the book she was using, which is a good book, Princeton Review, said that focus on the first 55 questions. Do not spend much time doing the last 5. The last 5 are the hardest. In other words, 56 through 60. And the one rule that you want to employ when taking the ACT is you want your 60 minutes to be spent the most efficient way possible. Would you rather spend those 60 minutes doing the hardest problems, or would you rather spend those 60 minutes doing the easiest and the medium problems? Given that all problems count the same, you don't get any more credit for doing a hard problem than you do an easy problem. The difference is you can do an easy problem in 10 seconds, and a hard problem might take you 2 minutes. So given that you only have 60 minutes to do 60 questions, and most everybody has issues with speed. I don't know of anybody that can take the ACT test and actually give the proper amount of time to all 60 questions. It's just probably not. I mean, if you're a genius and you're going to get, 99th percentile, maybe. But most people are not. Most people will get maybe 45 to 50 questions answered, or at least given their attention. So if you're only going to do 45 questions, let's make sure you do the 45 easiest and medium questions. And if you don't get to 15 questions, make sure they're the hardest 15. Now, there's a couple of ways to do that. You can, the first time through the test, make sure you see all 60 questions with time to spare. Then, as you go through those 60 questions the first time, you can put a single or a double check mark by questions that are hard and really hard. And what's going to happen is you're going to run out of time when you take the test, and you're going to have to go back and guess on those questions. And you never want to leave a question unanswered. You always want to at least guess. Okay? There's no penalty for guessing, and you have a 20% chance of getting it right. So why not guess? The biggest mistake you can make is not answering a question. That is just poor management of time. If you find yourself taking the ACT and you haven't guessed at some questions, then you haven't managed your time properly. This book, the Princeton Review, even suggested that you start the test off by going and guessing on 55 through 60 immediately. And when you guess, don't spend much time guessing. Guess A. There's no rhyme or reason to guessing. If you're going to guess, unless you can eliminate some of the answers, then, if I can eliminate E, then and only guess between A and D, that's better than having to guess between A and E. But what this book says is go through and guess 56 through 60, and then if you have extra time at the end and you've, given all the other questions your full attention and you still have time, then go and give those last 5 questions a shot. But by starting out the test, by immediately taking care of those last 5 questions in 15 seconds, all 5 of them, you're in better shape than somebody that gets to the 59-minute mark and realizes that they still have 10 questions they haven't looked at or answered, and now all of a sudden you got less than 60 seconds to guess at 10 questions. You know what I'm saying?
Yeah.
Okay. 33. Where does that equation, that's a linear equation because x is only to the 1 power and y is only to the 1 power. So the one thing we know immediately about this equation is that it's a straight line. It's not a curved line. It's not a parabola. It's not any kind of curved line like this. It's a straight line. Has to be.
Yeah.
Because it's linear. Okay? So what's the easiest way or the quickest way to figure out where that crosses the y-axis?
Put it in y-intercept form?
That's one way. It's not the quickest, but let's go ahead and do that way, because that's the way most people would do, because that's what you're taught. In other words, everybody kind of gets this in their head, y equal mx plus b. So if we can put this equation in this format, whatever b is the y-intercept, right?
Yeah.
All right, so let's do it. Put that in y equal mx plus b. What's the next line? What do I have?
I got 7y equals negative 3x plus 2. And then we divide the entire thing by 7 on both sides.
Okay, so what's the y-intercept going to be?
Y equals negative 3/7 x plus 2 divided by 7. So it would be C.
Good. Now, there's actually a little faster way to do this. Let me just point this out to you. The y-intercept is where x equals 0. The x-intercept is where y equals 0, right? In other words, if I have a line that crosses that and I want to know where that is, well, the one thing I know about it is the x-coordinate is 0. If I have a line that crosses there and I want to know what this point is, the one thing I know about it is that y equals 0. And that's kind of an important concept. Is your x-intercept is where y equals 0, your y-intercept is where x equals 0. So if I knew that, what's the best way to do this problem? I want my y-intercept.
Graph it.
Well, don't need to. All I need to do is let x be 0 and then solve it.
Like substitution.
Well, if I let x equal 0, it gets rid of that term. And I get 7y equals 2, y equals 2/7. To me, that's a little bit easier than having to solve the entire equation and put it into y equals mx plus b format.
I'm writing that down. Looks good. I like that.
No, that's a good thing to memorize. And the key thing to memorize is that the y-intercept is where x is 0, and the x-intercept is where y is 0. So what's the x-intercept on this thing?
The x-intercept, plug it, get rid of the y on this one, so it would be 3x plus 7 times 0.
You're getting the 7.
But we got rid of the 7. So 7 times 0, and that's gone. So then it's just 3x minus 2 equals 0. Then you add the 2, so you divide by 3, and then x equals 2/3.
That's the x-intercept. So whenever you're given an equation that's in standard format, kind of, and I mean standard format as opposed to slope-intercept format or point-slope format, there's 3 formats. There's slope-intercept, there's point-slope, and there's standard. Actual standard is ax plus by equals c. That's the true standard. So the actual standard format would be 3x plus 7y equals 2. But when you're given an equation that's in anything close to standard format, the fastest way to figure out your x and y intercepts is just to substitute 0 for x, which always gets rid of that term, and that'll give you your y-intercept. And if you want your x-intercept, substitute y for 0, which always gets rid of that term. So it's pretty quick to come up with x and y-intercepts using this technique.
Yeah.
And in fact, if somebody said graph this, the easiest way to graph it is to figure out the x and y-intercepts. Well, the x-intercepts was 2/3, so I know it goes through this point. The y-intercept was 2/7, so I know it goes through that point. There's the graph of that equation. I never even had to figure out slope. In other words, I was able to graph the equation almost immediately without figuring out slope. And that can be useful depending on the type of question, because any 2 points determine that line. I don't need slope, I just need 2 points. And if I have an x-intercept and a y-intercept, I have both points. All right. All right, it's 5:30. Why don't we stop with 33? And let me make a note here. We got through 33 of 293, and this is what, 9-9?
9-9, yeah.
All right. Terrific.
Awesome.
All right, Emily, I will talk to you next time.
Thank you.
Yeah, and I have an envoice that I'll send out this evening or tomorrow morning to your mom. It's
Okay.
nothing serious. It's $48, I think, is what's owed. In other words, she paid the original $80 before you started this summer, and that covered 4 hours of sessions. And then, so you've had just the 2 sessions this week, is all. Okay?
Cool. Thank you.
All right, you're welcome. I'll talk to you next time. Bye-bye.
Talk to you soon.